What's up, Math 6 students? This is Chapter 7, Section 6, Solving Inequalities Using Addition or Subtraction. And the essential question for today is, how is solving an inequality? You're probably faster at writing than I am with this thing. An inequality. Ooh! Don't you love how good this looks? Like solving an equation. Try to beat me. You probably already did. Congratulations. Ugh. Ah. Ugh. Done. Okay, how is solving an inequality like solving an equation? As always, I always encourage you to take a look at these words and think about what they mean, especially the word solving. We've talked about how solving means to find a solution, which is all of the values of a variable that make an inequality or an equation true. Okay, look for some clue words here that remind you of something else. Addition property of inequality. That sounds like the addition property of equality, which is what we used with equations. So it's essentially the same thing. When you add the same number to both sides or each side of the inequality remains true. So for instance, is 3 less than 5? Yes. Remember, the less than sign looks like the L, L-E-S-S. If I add 2 to the left side and the right side, I get 5 is less than 7. Is that also true? Yeah, same as 3 is less than 5. Now, what about doing this with a variable, right? So if we have x minus 4 is greater than 5, we could add whatever number we want to both sides, but we're going to add 4. Why? Because minus 4 and plus 4 are opposites. So that's 0, leaving you just the x, which is right there, is greater than 5 plus 4 is 9. And of course, because it's an inequality, we're going to have to graph these solutions because there are an infinite number of solutions to this inequality. X can be 10, yep, 10.5, yep, 11.2, yep. X can be all those numbers. What numbers can't x be? It can't be 7, because 7 is not greater than 9. 8 is not greater than 9. And 9. Why do we have an open dot? Remember, there's no line down here that means or equal to. So that means if I substitute 9 in for x, 9 is greater than 9. That's not true. So of course we have an open dot to show that 9 is not a solution. The same goes for the subtraction property of inequality. We can subtract the same number from both sides, and we also have a true inequality. Because these videos are limited to 15 minutes, I'm not going to go over the subtraction property of inequality as closely in the key idea. Let's just get to some examples. Okay, question. How do we solve the value of the variable that makes the equation or inequality true? Of course, might be values of the variable, like in an inequality, and inequality using addition. Okay, solve x minus 3 is, hopefully you know what that is, greater than 1. And then we're going to graph the solution, or solutions. Okay, I'm going to rewrite the inequality just like you will on your homework, so everything looks really nice. All right. If I want to solve this, I do not want x with the minus 3. I want just the x. So what can I do with minus 3 to make it 0? Well, I can add 3, because minus 3 plus 3 is 0. But if I add 3 to the left side of this inequality, I must also add 3 to the right side to keep it balanced, to keep the inequality true. Okay, minus 3 plus 3, as you know, those are opposites. That's 0. So what's left here? X is greater than 1 plus 3. That's 4. Okay, so what values can x be? Well, x can be all the values that are greater than 4. So we're going to put 4 in the middle of our graph. And I'm going to count by twos. 5, 6, and 3, 2. Okay? Now I'm going to look at this and go, wait, what values of x make this true again? Does 6 make this true? Is 6 greater than 4? Yes! I always think of Pac-Man's mouth. This is Pac-Man. His mouth would rather eat 6 than 4 Tic Tacs. What about 5? Does that 5 make it true? Yep. What about everything between 5 and 6? Yep, that all makes it true. What about everything above 6? Yep, that makes it true. And this arrow means all the things that go on beyond 6. And then it goes, keeps on going. All this is greater than 4, greater than 4. Oh, but what about 4 itself? Can I substitute 4 in here? Is 4 greater than 4? Nope. Open dot, which means 4 is not a solution in the solution set. Okay, our goal is to get the blank by itself. The, hopefully you know it, variable. Good job if you got that. I'm impressed by you. Use blank to undo the blank. Remember inverse operations? Use addition to undo the subtraction. So use addition to undo the subtraction. This thing does not do vertical lines. You have to really go slowly. Okay, subtraction. Oh! You know what? I don't have time to do the rest of subtraction. I'm just going to put subbed, and you know that means subtraction. Okay, check your solution by blanking a value that is included in your solution into the inequality. Whoa, I already told you inequality. Okay, check your solution by substituting, right? Isn't that what we're doing? We're substituting values back into the inequality to see if they make the inequality true. Value that is included in your solution into the inequality. Now, we kind of did this. Oh, I'm barely going to make it. Just barely. We kind of did this because I substituted values from the graph into this inequality. But technically, all these values make the original inequality true. So 6, for instance, right? 6 is highlighted. If I substitute 6 in for x, 6 minus 3 is 3. Is 3 greater than 1? Yes. What about 4? My claim is that 4 is not a solution. If I substitute 4 in for x, 4 minus 3 is 1. Is 1 greater than 1? No. 1 is equal to 1. So, of course, 4 is not a solution. So it looks like this all worked out. All right, let's move on to the next example. And the next example is, how do we solve an inequality using subtraction? How do we solve an inequality using subtraction? I didn't mention in the last example, but in the last example, we used addition property of equality in order to solve. And this one, we're going to be using subtraction property of inequality to solve. Okay, solve. 15 is greater than or equal to 6 plus x. And then we're going to graph the solution. This is an interesting one, and here's why. I'm going to write this out, but I'm going to leave a little space, and you're going to find out why in a second. 15 is greater than or equal to 6 plus x. In class, we talk a lot about how when there's no sign in front of a number, then it's positive, right? The sign that's to the left of the number is attached to it. So that plus sign, it's not attached to 6. The plus sign is attached to x. But then what's the mystery sign that's in front of the 6? Well, I can hear you already. Very nicely done. It's positive. It's positive. That's a positive 6. That matters a lot. So if I want to get positive x alone, here's the positive, here's the x. I know it's a plus, but it means right from 0. I want to subtract 6 because these are opposites. The inverse of positive is negative. And if I subtract 6 on the right side using the subtraction property of inequality, I must subtract 6 on the left side. Okay, 15 minus 6, hopefully you know that's 9, is greater than or equal to, these are opposites, that's 0, plus x. Do I put plus x? Well, plus x is the same as positive x. I don't need to put anything in front of it. So 9 is greater than or equal to x. Now, this is where I worry that you who's graphing it, when you're graphing at home, you're like, oh, I'm starting to see it which way this thing points. And that's which way you highlight on the graph. Let's think about this. What numbers would x be so that Pac-Man said, nah, I'm eating 9, not whatever x is? Well, 8, 7, let's do 10, 11. Okay, 7. If x were 7, would Pac-Man choose to eat 9 instead of 7? Yes. If x were 11, would Pac-Man choose to eat 9 instead of 11? No. So this is not a solution. 7 is a solution. What about 8? If 8 were here, would Pac-Man eat 9 instead of 8? And the answer is yes. So you're starting to see that from 9, it looks like we're highlighting to the left, right? We want all of these to be the values that x can be. But what about 9 itself? Or equal to means that 9 is a solution. If I substitute 9 in for x, is 9 greater than or equal to 9? It is equal to 9. Therefore, we make this a closed dot. And as you can see, I'm making a nice big closed dot. Oh, it's so good. All right, it's kind of scary. We can read an equality forwards and backwards. I think that they meant inequality, right? Because an equality is an equation. Thank you if you caught that. You're good. Oh, as you can see, this is working really, really well. Forward or backwards? What does that mean? I'm not sure that even means it. Wait. 9 is greater than or equal to x. Could I swap x and 9? Could I? Well, what was Pac-Man deciding to eat? The 9, right? Not the x. Well, Pac-Man's still going to decide to eat the 9, not the x. So wait, these two inequalities must mean the same thing. 9 is greater than or equal to x must mean the same thing as x is less than or equal to 9. Oh, hey, look. X is less than or equal to 9. That inequality might even make more sense when you see this graph. So cool. Forwards and backwards, that's actually really neat. The inequality 9 is greater than or equal to x is the same as x is less than or equal to 9. All right, guys, that's it for this video. I'm going to do the last question in the next video for 7.6b on our second day. So I hope you're doing well out there. I hope you're staying healthy, and I hope you're spending some time learning math. I'll see you the next time.